this weird bending, we first of all have to understand what's actually happening. Now, why is he not bending weirdly here, but is bending weirdly here? That is because here on the flat ground, we're not actually offsetting anything. If we take a look, Shift F1, debug here, we can see, well, maybe a little bit, but we're not actually hitting anything that would like result in an offset. As soon as we are like somewhere where we offset stuff, we're also offsetting over here in the eye case, the head and the neck. We're having an offsetting. So basically what we want, if we're standing, not walking, yeah, walking doesn't matter, walking is fine. Yeah, we want to offset when we're walking, or at least when we're walking a certain speed, we want this offset. But if we're like walking slow, standing, we don't want this. It's also probably going to like offset it. Oh my god, this is fast. So first of all, I want to put up the logic for you. We have the dark creature walk run here, right? So this one here where we set up our walk and decided where we walk in, right? And we can see he starts to walk on all fours, like around the speed of maybe around here. Let's say 300, okay? What we want is not to offset the neck and the head until we reach like 260. If we go to our animation blueprint, so that one here, yeah, and we already have a value called walk speed, because we use this to actually animate this here, to actually put it in here. If we go to state machine, into the walk run, we actually use this walk speed. So we already have a great value which we can use to do things with. We just simply have to get it into our control rig. So let's drag this out here. How do we get it in again? We have to go to our control rig and first of all create a variable which we call walk speed. Yeah, and we're going to change it to a float. And we're going to hit instance editable so we can grab it from the outside. Go back to our unMBP, select the control rig node, and down here under input, we also now have a walk speed variable which we can expose. And we have it here, and we just plug it in. And now we get access to this walk speed inside our control rig. So down here, I'm going to just grab the walk speed, get it, and then we want to remap. So, and what do we want to remap it with? Now, we can just take a look here. If it's 0, this thing here should also be 0, outputting 0. If we're at 200, let's say 280, it should output a 1. So if we're at 0, it should output 0. If we're at 280, it should output a 1. So we're blending it fully in. We're going to remap to clamp it, so we can't overshoot. We're going to drag this out, and we're going to use interpolate. It's essentially just like a mix RGB where you have like 2 values and 1 blend value. And this goes into the time, and A and B are the results. We can now plug this in here, just over here, and we can right click, watch this value, just so we see what is what when. Yeah. Hit play, use our debug here, and we can see when we're walking, it's outputting B, yeah, because in the B we have currently a 1, so walking, not walking, walking, not walking. So we want to offset only when we're walking, so this offset goes into B. And we're going to do the same thing with the head, because both the head and the neck are going to get pushed down. So let's make a second interpolate here. And this also goes into the time, and this here goes also into B. You go into the add. So now, if we walk over one of the edges here, the head and the neck themselves don't get pushed down. They are pushing down because the hands drag them down. That's how it works. So we also have to do this for the hands. The indexes shouldn't have this. So what we need to do is we need to copy the interpolate here, plug this into the time, and this offset here, the index offset goes into B. In here, need another one for the other hand as well, into the B. The time, you go over here. We're making this a bit more tidy in a second. But with that plugged in, we will see that the hands are not pushing down, the neck is not pushing down. Actually, it might be fine if we, yeah, but at least we're not like breaking when we're standing anymore. And here it's working now as well, because we're standing and it's not pushing the hands or the neck down. So this is already pretty good, I would say. So let's clean this a little bit up here. Right, compile. So essentially what's happening is when we jump here, yeah, you can see a lot of snapping. So we're standing, neck, head and hands are not offset. We're running, neck, head and hands are offset, and we're jumping and they're still offset, yeah, and they snap. The reason they snap is, and let me go to the blueprint and make a 0 out of the time dilation here real quick so I can show you, is back to our, so we're running and we're jumping, and the reason it snaps is because it loses the connection here. It's offset, but then it's too far off to still trace, and then it's snapping off. It's landing and it's snapping on again. So meaning we have to turn off at least the pelvis. We still want the hand to trace, but we want to turn off this offset here, the neck and the head offset when we're jumping. For that we have the jump already in here, but currently it's just a boolean, so on or off, which also will result in some sort of snapping. So instead of using the boolean as it is, I'm going to find myself a load here, otherwise I cannot get it, drag it out and type an if, and we get a float if here. Let's disconnect this, I just want to get a node. And we can plug this, get an air or not in here. So if it's in air, it's true. If it's not in air, it's false. So I'm going to put in a 1 here in the true. And now we have a float. So basically, if it's in air, it's outputting a 1. If it's not in air, it's outputting a 0. It's a bit more straightforward. And now with this value, we can interpolate it. We can already take one interpolate here. So interpolate, float. This is actually the wrong one. Interpolate, and we want the one under simulation. Yeah, interpolate simulation, not vector. And you can see we get like a giant node. The only thing that is really interesting to you is to check the interpolate result. Yeah, so it's actually working. And then the increase and decrease speed. And because we're going to use this a few times, we're going to make a variable for that. So let's just make a new variable and call this in air interp. So, and we get this out here and set it. And we're just going to set this here in the beginning or whatever. Now let's hit compile, right click, watch result, and we're going to hit play and open the debug here. And now we can just take a look. I should probably change the time dilation so I see a little bit better. 0.03, I guess. Play, debug, and we can see it's at 0 because we're not jumping. Slow-mo, jump, and you can see it's interpolating up. It's interpolating up. And if we're landing or have landed, now it's going to interpolate down. And we get some sort of a smooth value. Yeah. If you want it to increase faster, so basically when you start jumping, so the value is increasing. Yeah. If you want it faster, you can just here interp speed increase, use a bigger number, use like a 500 and you see it. 500. Jesus Christ, what the heck? What the heck is that? Interesting. I don't know. Yeah, you can see it's instant. Yeah, with as higher value you get. So I think let's stay with around 10. 10 might be fine. We get basically a value which we can use to switch things with a smooth value. Yeah, and what we want to do is we want to lerp over here again. Over here, it's choosing if we're walking or not, right? On the walk speed, we're interpolating if walking or not walking, and we can just copy the interpolate, and we know if it's 1. It's going to be B. So now we get our interp, get. And if this here is 1, we're actually jumping. So we plug this in here, this is the time. So if this here is 1, we're actually jumping. So the jump resolution, jump solution needs to be here, which is 0. And the other result needs to be in A. We now plug this in here, watch this value, file, play, debug. And there we go. The result of the float is currently 0. And it's starting again. We're jumping. Probably don't see a difference currently because we also need to plug this into this one here. Don't really need to add here, it's just like this here goes into the time, this here goes into A, and then in here. So with that, the neck and the head are not offset when we're jumping. Let's drag this a bit cleaner here, go a little bit further back in here maybe. Let's get rid of the add here for a second. And make a frame, turn off offset when jumping. And we can see it's already better, though we probably have to do it with the pelvis as well now that I realize it. So essentially exactly the same thing, to interpolate with a speed for the pelvis. We offset the pelvis right up here. We do this before that, okay? Paste this in. So if we're jumping, we get the B result. So this goes into A, compile. Let's take a look. And we still get a little bit of snapping from the feet and the hand. The only thing that's currently snapping are the feet and the hand. So let's also turn off completely the feet here with the same logic. So the feet are here. So we just paste this in here, just like that. If we're jumping, we get B, so this goes into A. Z here. And we also want to turn off the other foot. So you go in here and then into this one here. And with that, the feet also should like turn off. There we go, we get less snapping. There's a little bit of snapping still on the feet. This is probably because the boolean is not interpolating quick enough. So let's make the boolean a little bit quicker now. Yeah, it's not interpolating fast enough. So the increase has to be a little bit faster. For that we go lower, let's say like a 6 or something. We don't really want to turn off the fingers completely. Currently it's pushing up that weirdly because the fingers are still going up, right? The fingers are not turned off. But I don't want to completely turn off the fingers because if we're jumping on something, I want the fingers to like move up. If we completely turn it off while jumping, they would just go through. We do it a little bit different then. If we're jumping, so we are still using this variable here, the setup here. By the way, we should probably make a proper frame for that. See, turn off when jump. Turn off offset when jump. Same thing here. Turn off offset when jump. What I want to do is decrease the tracing amount. Because when we're jumping, you see, and it's snapping as soon as it doesn't have connection to the ground anymore. And then you can just watch the middle part here, the middle traces. As soon as they don't connect anymore, they are snapping. A little bit is fine, it can be solved with an interpolate. Too much of a distance is just too much. So what we can do is decrease the tracing distance when we are jumping. So all we need is again our setup here. Copy this, go to the traces. Now the feet are generally fine, there's a little bit snap which can be solved with a interpolate. But here we have the index. And essentially we could do this for the feet as well, whatever. But we want to change out the Z depending on when we jump and when not. So I'm going to copy this. B is when jumping. So we're going to plug this in here. B is when jumping, so A is running. And we want to decrease this. Let's decrease this to, let's say, minus 25. It can actually be, or minus 20, it can actually be pretty low. We do the same thing for the other hand. Put this in here. Compile. Now let's take a closer look what's happening when we're jumping. We're running, and slow-mo and jump, and you can see how the trace distance decreases. Maybe not early enough, probably decrease early enough. So let's make this a little bit lower. Instead of a 20, why not just a -1? Alright, so the reason why it jumps a little bit weird here is because we forgot to set some values here. For example, at the pelvis. We are adding the offset to the pelvis, right? When we're like walking or whatever. But if we're jumping, we just set it to 0, which is not quite correct. We want to set it to its default. Yeah. So that's one thing we do. And if we now jump, you can already see the pelvis is a little bit further up where it should be. Now the legs are a little bit weird, right? So because we also forgot the legs, we go down here. We are also interpolating to 0 and not to its default. So we need to interpolate to its default. Same here. Both legs. If we now hit compile, we get the proper jump and it already doesn't look snappy anymore. If we slow-mo, we will see a little bit of snapping. That is not a big deal. This much can be solved with the interpolator. It's actually pretty good, almost better than the one I made. A little bit of snapping, this is not a big deal. Because if you're like jumping, we already don't see it anymore. So we can save that, that's pretty decent. And yeah, that's essentially it. To I added a little bit more. I'm going to give you a few side mods here in a second. But let's test it. I mean, it's pretty good if we're standing. We're not getting offset. Now you can see here's a little bit of a weird thing if we're like walking on the edge. That is because in the traces are actually spheres that get shot down. So they have a radius. If we make this radius smaller to like a 1, it's going to get more accurate. Doesn't mean you should go all the way down. At some point it just shoot through because it's too small, but a 1 I think might be just fine. So let's try a 1 here and let's see if it is a bit more accurate now. Yeah, it's a bit more accurate. Though you probably want to decrease I mean, we could decrease the tracing distance depending on if we walk or run. So we don't get like this weird thing here and rather clip a little bit instead of like being inside there. But that's up to you then.